Okay, sorry, that last one got cut off. So on the outside here, you have, let's see, 7 times 2. I don't know where this 3 came from. Root 3. So you've got 7, this shouldn't be there. So 7 times 2 is 14. And then you've got x cubed and y squared. And then on the inside, you've got 3xy. Okay, so that's how you finish up that problem. So just remember, what's on the outside stays on the outside, what's on the inside stays on the inside. Okay, once you've simplified everything. All right, so now I need to go back and erase this because I need more room for the last problem. All right, so with 27, you have 9 times 3. Square root of 9 is 3, so that's going to be 3 root 3. With x to the 5th. So remember that one breaks down. The next even number down will be x to the 4th times x. Square root of x to the 4th is x squared times x. And then with the square root of y squared, that's just y. Oh, sorry, that was x squared root x. Square root of y squared is just y. And then the square root of z is just square root of z. That doesn't reduce at all. So on the outside, we have 3 x squared and y. And on the inside, we have 3x and z. All right, so that's that one right there. Okay, so next we're going to talk a little bit about multiplying and then dividing. So with multiplying, what I just said on the last slide, what's on the outside stays on the outside, what's on the inside stays on the inside until you do a radical. Okay, so some of these I'm going to tell you it's easier to multiply and then simplify. Some of them it's going to be easier to simplify first and then multiply them. So I'll do a couple each way. With this first one, root 5 times root 10, neither of those are perfect squares. So you can combine those to be 5 times 10, which is 50. So square root of 50. Now, 50 is a perfect square. So that reduces down to 25 times 2. Square root of 25 is 5, so you get 5 root 2. Okay. With 3 root 27 times 4 root 24, you can just multiply 3 times 4 and 27 times 24. Those are bigger numbers though, and I don't want to have to get my calculator out to figure out what that is and then what perfect square goes into that because that's going to be a really big number. So I'm going to choose to simplify this first. I know I have the 3. 27, the perfect square that goes into that is 9. So square root of 9 is 3. You've got 3 times 3, which is 9 root 3. And then with 24, 6 goes into that. That's 6 times 4. So, wait, that's not a perfect square. Oops, okay, hold on. What perfect square goes into that? 4. 4 is the perfect square. Oh, I did have the 4 over there. Never mind, I just looked at the 6. Okay, so anyways, 4 is a perfect square that goes into that. So that's going to be the square root of 4 is 2. So now you have 4 times 2, which is 8 root 6. Now I can do 9 times 8, which is 72. And then root 3 times root 6 is root 18. But now you're not done because root 18, a perfect square goes into that, right? 9 goes into that, so it's 9 times 2. Square root of 9 is 3. So now you've got 72 times 3 times root 2. So that is 216 root 2. A lot of simplification there. Okay, so the next one, x to the 4th times x to the 5th. Again, you can multiply them. So when you multiply x to the 4th times x to the 5th, you get x to the 9th. So then we know that x to the 9th can be split. You would do x to the 8th times x. Square root of x to the 8th. 8 divided by 2 is 4, so that's x to the 4th root x. That totally works. Or you can say, oh wait, I know the square root of 4. That's 2. And then x to the 5th breaks down to x to the 4th times x. Square root of x to the 4th, 4 divided by 2 is 2. So then you have x squared times x squared is x to the 4th root x. So either way works there. Okay. With the next one, again, you can multiply or you can simplify first. Doesn't matter. Let me show you this one in multiplying. If we do 10 times 32, that's 320. X to the 5th times x to the 4th is x to the 9th. All right, so with 320, I know that 16 goes into 32, so that means 16 is going to go into 320, And that's just 20 times because there's the zeros there. So I'm going to start with that. I know there's a bigger perfect square that goes into that, but I'm not quite sure what it is yet. So I'm going to start here. So square root of 16 is 4. 20, I know that a perfect square goes into that, right? 4 goes into that. So that's going to split to 4 times 5, which ends up being square root of 4 is 2. So 4 times 2 times root 5. So that's going to be 8 root 5. Okay, and then x to the 9th. X to the 9th, we just did that over here, right? The square root of x to the 9th is x to the 4th root x. So that's going to be x to the 4th on the outside, x on the inside. Okay, so that would be that one. All right, next we are going to look at dividing. Okay, so with dividing, biggest thing to remember is you cannot leave a radical in the denominator. Okay, so we're going to be rationalizing those. However, you want to be able to simplify if you can. So with 27 and 12, 3 goes into both of those, right? So you can put this into 1. 3 goes into both of those. 27 divided by 3 is 9. 12 divided by 3 is 4. Then we can split them back up, right? The square root of 9 is 3. The square root of 4 is 2. So that's all. Okay. With the next one, 4/5 on the outside, that does not reduce, so that's going to stay 4/5. And then the 12 and the 54, what goes into both of those? Let's see, 6 does. 6 goes into 12 twice. 6 goes into 54 9 times. So if you split that back up, root 2 is not a perfect square, so that's just going to stay root 2. Root 9 is 3, so then on the bottom you have 5 times 3, which is 15. Okay. With root 7x cubed and 27. So 7 and 27 don't have a common factor, all right? So I'm just going to split them up. You have 7x cubed, you have 27 on the bottom. I know that with 27, that splits to 9 times 3, which would be 3 root 3. Okay, on the top, 7 doesn't have a perfect square, but x cubed, that can be broken down to x squared times x. Square root of x squared is just x. So it's going to be x on the outside, root 7x on the inside. Now, with that 3, root 3 on the bottom, okay, we cannot leave a radical in the denominator. So what you're going to end up doing is multiplying top and bottom by root 3. Okay, so 3 and then root 3 times root 3. Think about that. What is root 3 times root 3 is root 9, which is just 3, right? So the whole point of multiplying by itself is to get back to 3. So you've got 3 times 3 on the bottom, so that's 9 on the bottom. On the top, the 7x and 3 are both underneath the radical, so that's just going to be 21x underneath. So x root 21x all over 9. Okay. With the next one, we're going to split that up. That's x to the 7th and root 24. So 24 splits to 4 times 6. Square root of 4 is 2. So that's 2 root 3. On the top, x to the 7th splits to x to the 6th times x. Square root of x to the 6th. 6 divided by 2 is 3. So that's x cubed root x. Then from there, you've got 2 root 3. So we've got to get rid of the radical in the denominator. So we're going to multiply by itself times root 3. So on the top, root x and root 3, you can combine those to be just root 3x. On the bottom, root 3 times root 3, again, is root 9, which is just 3. So you would have 2 times 3 on the bottom, which is 6. Do make sure, like, you can't simplify there. Like here, I can't. X cubed and 6, I cannot simplify them, so it stays like that. Okay. All right, 2 more problems, and then we will be done. Okay, so with this one right here, we're multiplying. All right, so again, what's on the outside stays on the outside, so that's going to be -6. And here you have a choice. Root 8, you know, simplifies, so you can simplify that and then multiply, but I'm just going to go ahead and multiply. 8 times 5 gives you 40. So then root 40, what perfect square goes into that? 4. It's 4 times 10. So now root 4 is 2. So negative 6 times 2, you end up with negative 12. So negative 12 root 10. Okay. The next one, what I'm going to do here is I am going to multiply. Okay. Part of it is because I'm kind of thinking ahead. I know 12 reduces, but 12 times 3 is 36, and 36 is a perfect square. So it's just going to be easier if I just straight multiply, right? So what's on the outside, 6 times negative 4 is negative 24. And then the inside, 12 times 3 is 36. X cubed times x to the 7th. 3 plus 7 is 10. Now you know why we reviewed exponent rules, right? Y to the 9th is just by itself, so that's y to the 9th. All right, so then with this, root 36, x to the 10th, y to the 9th, I'm going to split it up and do root 36, root x to the 10th, and root y to the 9th. So square root of 36 is 6. Square root of x to the 10th. 2 goes into 10 5 times, so that's x to the 5th. And then y to the 9th needs to be broken down to y to the 8th times a. Square root of y to the 8th, 2 goes into 8 4 times, so y to the 4th root y. So now we are just multiplying. Negative 24 times 6, that is negative 144. You have x to the 5th and y to the 4th, both on the outside, and then root y, that one stays on the inside. All right, so that's it. Now I want you to go ahead and try that practice, and on Thursday and Friday we'll be going over that.